Inferential statistics is essentially concerned with drawing interpretation of the data obtained from a sample of subjects. In the course of this interpretation, we infer something regarding the population characteristics from our study of sample characteristics, or more technically, we can say in inferential statistics we try to conclude something regarding the population parameter from the study of the sample statistics. For example, from the study of the mean score of a sample of subjects drawn from a defined population, we can say whether the sample mean represents the population or not. We can infer whether the two samples belong to actually the same or different population. If the mean difference between the two samples is found to be statistically significant with respect to the character studied, and the corresponding inference will be that the two samples do not belong to the same population, so far as the characteristics under consideration is concerned. On the other hand, if the mean difference of the two samples are on the characters that are studied is found to be statistically insignificant, the corresponding inference will be that the two samples belong to the same population with respect to the character studied. Now, for statistical inference, obviously, firstly what we need a defined population, so that accordingly we can make a representative sample. We can select a representative sample from on which the study is being conducted. Now, about population, we have already discussed in the class that it is basically the aggregate or totality of the objects or the individuals regarding which the inferences are to be made in a sampling study. One of the important steps in the design of a sampling study is the specific character of the population to be studied, because unless and until we have this specific character, a representative sample cannot be drawn from it. The investigator is responsible for the development of a set of rules which clearly determine whether or not a given object belongs to the population under the investigation. Now, based on that defined characteristics of the population, we draw the sample. That is the next step of inferential statistics. We draw the sample from the population, and by sample we mean a collection of objects consisting actually a part of the population which is selected for making inferences about or estimates of certain population facts. The exact word that we use, I already discussed in class, that it has to be a representative sample, and to be a representative sample it needs to fulfill certain criteria. What are those? Like the proportions of different types of individuals or events in the sample should conform to their proportions. This makes the sample conform to the population with respect to the distribution of frequency of cases of diverse types or values. Next, the variation between the members of the sample should not exceed the range of variations predictable by the laws of probability on the cases of similar variations in the population. And lastly, the different samples drawn similarly from the population should have close values of the statistics like mean, median and SD, that is the central tendency. It should be reasonable to assume that the arithmetical average of any such statistics of different sample actually should coincide with the corresponding measure of the population. That is, the statistics should actually coincide or match the measure of the parameter. Now, next in the line will be setting of a hypothesis. We will start doing it with the null hypothesis. Now, the word null, it actually means a no hypothesis. This is basically a starting point of any statistical test in which there has to be a statement of null hypothesis which actually denotes a no different hypothesis. That is, it says that there is actually no difference between the two samples under the study there is actually no difference between the two samples under the study. It makes a judgment about the obtained difference between the samples are due to some true difference or due to some chance errors. That is, the no variance, no hypothesis, before starting we assume that there actually exists no difference between the samples that we are to study. That is, the characteristics of the samples that are in the study, they actually do not differ from each other. Now, another kind of hypothesis is alternative hypothesis, and as null hypothesis is a no hypothesis, alternative hypothesis is basically an yes hypothesis. If we start this with this hypothesis, then we actually write it in affirmation that there actually exists a difference between the two sample mean or the population mean, as the case may be. This hypothesis is tested against an alternative hypothesis, which is an operational statement of the investigator research hypothesis that indicates that the mean difference is noted, and that is, it has a significant difference between the two means, that is the sample mean or the population mean. That means for alternative hypothesis, before going on to the inference, we are starting off with an assumption that there actually exists a difference between two means or the two samples under the study. But in case of the null hypothesis, we are starting with a no hypothesis, that we are starting with the assumption that there actually exists no significant difference between the two samples. Next will be in the line obviously setting up of a confidence level. Now, in this part, the experimenter has to take a decision about the level of confidence or significance at which he is going to test his hypothesis. At this time, he may decide to use 0.05 or 5% level of significance for rejecting the null hypothesis. That is, when the hypothesis is rejected at 5% level, it is said that the chances are 95% out of 100% the hypothesis is true, and only 5% chances of 100 out of 100 it is true. That is for the null hypothesis. That is, it is if we consider this, that means if this test is done 100 times, then out of this 100 time, 95% time there will be no significant difference. That is the null hypothesis. There will be no significant difference, but there are only 5% chances that it can be due to some chance factors that there exists some difference. At the other times, he may prefer to employ a more stringent test, and therefore significance level of 0.01 or 1% level of significance can also be used. If a hypothesis is rejected at this level, the chances are 99 out of 100 that this hypothesis is not true, and only one chance out of 100 that it could be true. This is actually in case of the null hypothesis. We basically start with the null hypothesis, and whatever assumptions, whatever understanding we do, we actually do on basis of the null hypothesis. So it is like 99 out of 100 the hypothesis is not true, but there is only 1% chance that it can be true. This level on which we reject the null hypothesis is established before doing the actual experiment. That is, we have to select it beforehand. We have to decide which level we will select for testing the hypothesis. Now, from this discussion, it is clear that this choice of level of significance must represent a compromise effort at controlling the two types of error which may occur in testing the statistical hypothesis. Now, why we say there can be errors in the testing or in this inference, like as we have said, ki for whatever we select, the 95% rule or 99% rule, in each case we actually leave 5% and 1% chances that my inference might not be true. So whenever we have this kind of chance factors, then there can be a time where there can be wrongful rejections of null hypothesis or wrongful acceptance of null hypothesis, and accordingly there can be errors of inferences. Now we'll be knowing exactly what are these errors of inferences. Now, because this inference of a test is made through a rejection or acceptance of null hypothesis, according to the probability of its being correct, the inference actually suffers from a probability of an error due either to the wrongful rejection or to the wrongful acceptance of null hypothesis, depending on the probability that worked out. There may be thus be two types of actually errors. It is called type 1 errors and the other is called the type 2 error. Type 1 error of inference consists of a wrongful rejection of a true null hypothesis. In other words, it is an error made in accepting the accidental and insignificant experimental results as significant. Now, whenever we are saying we are accepting a null hypothesis, or whenever we are saying that this is a rejection of null hypothesis, we said null hypothesis is a no hypothesis, so we are starting that there actually exists no significant difference between the sample means. Okay, so if this is true, if really there is no difference between the sample means, we are to accept the null hypothesis. But if the inference, it comes out that there actually exists a difference between the sample mean, then we should actually reject the null hypothesis. Now, type 1 error is basically a wrongful rejection of null hypothesis. That is, we are rejecting null hypothesis. We are saying that there actually exists a difference when there is no difference between the groups on the sample mean. Thus, the rejection of null hypothesis, when in fact it is true, constitutes a type 1 error, which is also known as an alpha error. It can be said that 0.05 level of significance, the experimenter commits a 5% type 1 error when he rejects a null hypothesis. Some investigators may want a more stringent list, and 0.01 level is one such level where the investigator commits a type 1 error of 1% only. The 0.01 level suggests that 99% possibility exists that the obtained results are due to the experimental treatment, and hence once in 100 replications of the experiment, the null hypothesis would be true. Sometimes the investigator wants even more stringent test of significance, and for this he can also choose levels of 0.001, which is uncommonly used in the behavioral researches obviously. This level suggests that one time in 1000 replications of the experiment the null hypothesis would be true, and in 999 replications out of 1000 the obtained result can be attributed to the experimental treatment. Now next, when we talked about the type 1 error, we said there are actually two types, type 1 and type 2. So what is type 2? In testing the significance of the obtained statistics, sometimes the investigator actually accepts the null hypothesis when it is false. This error is technically known as the type 2 error. Now, as we said, for the type 1 error, that was the wrongful rejection of null hypothesis, and type 2 error is the wrongful acceptance of null hypothesis, or it is also called the beta error. As we call type 1 as the alpha error, it is also called a beta error, where we actually accept the null hypothesis. That means we infer that there actually exists a significant difference between the two sample means when there is no difference between the sample means. Acceptance is when we say that there actually exists no difference because it's an acceptance of null hypothesis. So we say when there is actually no difference between the group, as it is a null hypothesis, but actually there was a difference between the group. It is obvious from the interpretation that can be reduced by putting the alpha level at 0.01 or 0.01 level or 0.05 level, but as we reduce the chance for making a type 1 error, we actually increase the level for making the type 2 error, where we do not reject the null hypothesis when it should be rejected. Therefore, as we decrease the possibility of making the type 1 error, we also increase the probability of making another type of error. So the research workers must be cautious with these situations and should try as far as possible to limit the probability of making such errors. Now next will be the degrees of freedom. Now what is this degrees of freedom? Degrees of freedoms or basically are denoted by letters D and F. That is DF. We call it as DF and are the initials of the keywords. The concept of degrees of freedom as it applies to statistics is fundamentally mathematical and is difficult to express and we can make it simple, or in simpler terms we can say it like the number of DF is always some functions of the number of observations from which the statistics is computed, a function which enters in the mathematical formula for the sampling distribution of the statistics. The number of DF of a given statistics is equal to the number of observations involved minus the number of necessary auxiliary values used in the computation of statistics. So as particular statistics may not have a single sampling distribution but rather a family of distributions, each member of which has an appropriate distribution of these functions. That is, for a given number of degrees of freedom, the number of DF of a statistics is used in statistical work simply to identify the particular mathematical model for the sampling distribution of the given statistics. Now these are actually the steps that we take while doing a statistical inference. That is, when we'll be doing a t-test or whenever we'll be doing a statistics, we'll start off with the hypothesis, we'll be selecting the confidence level, the degrees of freedom. So in this way, these are the steps that is to be kept in mind while doing the statistical inference. If anything is not clear or you have any doubt regarding any of the points, you can surely make a note and make it known to me so that we can discuss it in our next class. Thank you, class.